Yeah, we are live. You can start the meeting whenever you want.
You can.
Asmitha, did you hear me?
Yes, ma'am. Soundarya will start the meeting.
Good evening, ma'am.
Good evening.
Can I start now?
Yes.
Okay. Good evening to one and all present here. We all have gathered here for a webinar of our VINN club. And good evening to one and all present here again. And I am glad to welcome you all to this webinar. A special welcome to Dr. V. Madhurima ma'am, who is always our supporting stone. And today's talk is going to be about astronomical events and space missions 2022 and 2023. Whenever we are exploring some astronomical events, we are very happy to see whatever is happening around outside the world and around us. And we are always interested in exploring them in every eye-opening of the universe. And universe have never failed to unveil its new faces to us. And even in future, we are very excited to know how it is going to happen and when it is going to happen. Even though we can't able to start an astronomical event by our own, but we are again and again interested in exploring our universe. That's the enthusiasm going to make this webinar a successful one. And I'm glad to welcome our today's speakers. There are two speakers today, and the first speaker is Nebula SU from Integrated MSc of Central University student. And I welcome Nebula to give her talk now. Over to Nebula.
Good evening, ma'am.
Good evening.
Shall I share my screen?
Yes, go ahead.
Okay. Am I audible to you all?
Yes, you are audible.
Yes, Nebula, you can continue.
Or something.
Good evening.
Yeah.
Ma'am.
Go ahead.
Good evening, all. I am here to share some details about upcoming astronomical events till June 2023. Before going into these astronomical events, I thought it is useful to know about a celestial sphere.
1 minute.
Yes, ma'am.
Nebula, do you have your YouTube or something?
Ma'am? Hello, ma'am.
Sorry, that was from my side. My mistake. It was. Please go ahead. Now there'll be no problem.
Okay.
Sorry, the problem was from my end.
Okay. First, I feel I have to start from what is celestial sphere. When we are observing, we are going to observe all these astronomical events and these objects, how do they revolve, seems to revolve around us. So these astronomical objects are far away from us. So by actual observations, like looking at the dark sky, we cannot know what is the distance between us and these astronomical objects. So we construct a tool to describe the location of these objects in the night sky. When we come out of our home and look upon the night sky, it seems like we are inside a dark sphere, which is having all the constellation, planets, and all the celestial bodies like moons are embedded on the inner surface of the sphere. So we are constructing a tool like we have on Earth, we have latitudes and longitudes to locate particular position on this Earth surface. We are having equivalence of latitude and longitudes on the celestial sphere also. So this celestial sphere having center at the center of the Earth, and its poles and equatorial planes are coincident with those of the Earth. For centuries, people are observing the celestial sphere. How do they move throughout the night, and how do they move throughout the year? And with that observation, people use those results to navigate ships and find what are the seasons, predict the seasons and rainfall and everything. So when people started observing night sky, there is a people get excited by the phenomenon called meteor showers. Um, First, we are going to see about meteor showers. Nearly 50 tons of space debris crash into Earth every day, and the most natural causes of these debris are from asteroids and comets. In the case of asteroids, we all know there is an asteroid belt between Mars and Jupiter, uh, where all the asteroids are revolving around Sun in a common orbit. So when two asteroids collide with each other, their force of collision can able to push those asteroids into the Earth's orbit. So when Earth comes across these asteroids orbit, uh, it we can get to we can get the light shows called meteor showers. And other concept was from comets orbit. Comets uh, revolve around sun in an elongated elliptical orbit. Sometimes it comes very close to sun, and other time of their orbital period they are far away from sun. When they come close to sun, their orbits will intersect with Earth's orbit, and when Earth reaches these intersection positions, these comets used to leave some rocky materials by their way. So these are called meteorite streams. When Earth comes in contact with those meteorite streams, they are get attracted towards Earth because of Earth's gravity, and the debris race into this Earth's atmosphere with the speed ranging from 25,000 miles per hour to 1,60,000 miles per hour. Because of its high speed and there is air resistance, so friction creates a vast amount of heat. This heat is enough to vaporize and ionize the surface of these meteors, surface of these meteorites, and it can also able to ionize the surrounding gas. So this looks like a light streak for us, and this is commonly known as the shooting stars. Sometimes when they on their way they get dissipated into the atmosphere. Some of them reaches the ground, and the meteoroids that survives its passage through the atmosphere and reach the surface of Earth are called meteoroids. Most of the times they are of the size of pebbles or grains of sand, but sometimes they are large. The largest known intact meteoroid is named as Hoba meteoroid. It is having mass more than 60 tons, and uh, it is believed that it comes to Earth 80,000 years ago. And based upon, I already told, right, there is light streaks. So their colors depends upon what are the materials present in the particular meteoroid. If the meteoroid contained abundant of iron, then the color will be yellow. And if that is nickel, then it will be green and so on. So most of the meteoroids are of having iron. So most of them will show yellow color streaks. And every year, Earth come across these meteoroid streams, and there are 21 meteoroid showers a year can be seen from Earth. Most of them are occurring between August and December, because at that time the path of the Earth contains more these intersections from comets orbits and asteroids orbits, and so these phenomenon are cyclical and occur at some regular intervals. And if we are looking from Earth, it looks like these intersection points and the constellations on the background. As Earth rotates, but they are still, and Earth rotates. When we are looking from Earth, it looks like Earth is still, and these intersection points are rotating with the constellations on the background. So it looks like they are coming from those particular constellations. So they are named after the constellation they are appear to originate from when we are seeing from Earth's surface. So to watch these meteor showers, what do we need? First, we need time and patience, because most of the meteor showers are having can produce around 20 to 30 meteors at its peak per hour. So we do need time and patience, and a secluded viewing spot away from city lights, because if we are having some light source, even not so bright, close to our observation point, and there is some bright light which is far away, then this close light that is closer to us will fade out the light that is far away, right? So we have to move away from the city, inner city sky, and if we are how much far away we are from the city lights, we can get a better view on the stars and these meteor showers. And we do also need dark sky with no moon. This is not in our control, but we can select appropriate time where we can get more meteors falling, and time where the moon's light will be not so bright. And I already told you, right? The constellations, or these looks like they are radiating from a particular constellation. We don't have to look. They are not only coming from that particular position of sky. They can appear anywhere in the sky, and we can see in these events by our naked eye. And meteor showers have been mesmerizing us for centuries, and they are the beautiful reminder as we are in the solar system. Solar system means it is not just planets and moons which are rotating in a nearly known elliptical orbit. It is also having asteroids and comets and some unpredictable events like asteroids collisions and all. So this reminds us that we are a part of busy and mystical solar system. Now this is the meteor showers going to happen this year. These are names of meteor showers named after which constellation they are coming from: Aquarius, Perseids, and all. These are the periods in which these meteor showers can happen, and they are interfering. These periods are overlapped with each other. So on the same day, we can get to see more than one meteor shower, and it peaks on these days. And these are the moon phases when and on the peak day. So if it is new moon, it is we can get a good show. We can get to see a good show. If they are near full moon, then we can't see the faint meteors which are having low intense light, and but we can see the bright ones. And if you want, you can take a screenshot of this particular tabular column. And Leonoids are having some unique behavior, because every year you can get to see this from November 6 to 30, and peaks on around November 17 or 18. And but in every 33 years, this meteor shower will become meteor storm, where you can get to see more than 100,000 meteors per hour. So this is an unique meteor shower. And germinates having 120 meteors per hour. More number of meteors can be seen in per hour. And these meteors are multicolored because there's 3200 Pantheon is an asteroid which contains more minerals of different kind of minerals. So it is multicolored, blue, green. You can see many color the asteroid meteors. And this is from others. And from here you can notice from August to December there are many meteor showers, but outside these particular period we have very few meteor showers. And we also have planets on the celestial sphere that are moving westwards, eastwards, based upon their orbital positions. So at some position, when planets comes to some positions, we can see those planets very clearly. They are much closer to Earth, and they are far away from Sun. At some positions, they are far away from Sun and close to Earth. So we get to see their features. Sometimes if the Mars is at some position, we can able to see their surface landscapes with the simple telescopes. So to note down their position, there is a term called elongation. Elongation is the angular separation between Sun and particular planet when we are looking from Earth. So there are two kind of planets: inferior planets, superior planets. As you know, inferior planets or Venus, Mercury. These are inferior planets. Superior planets orbits around Sun outside this Earth's orbit. So for inferior planets, we get to see them very clearly when they are at greatest elongation. That is the angle between this. Angle between the planet Sun with respect to Earth is large. So when these planets are at this position, the Sun it is away from Sun, so there is no fading effect due to Sun's brightness, and it can be seen very clearly. And there are two great elongation: greatest eastern elongation and greatest western elongation. So when inferior planets are visible at sunset, it means they are at their greatest eastern elongation. And if they are visible before sunrise, then they are near its greatest western elongation. And this elongations happen periodically as Earth is moving in a periodic manner and planets are also moving in a periodic manner. So it happens periodically. And for superior planets, that position is called opposition, where the Earth, Sun, and that particular planet is aligned in a straight line. And so the planet will be completely illuminated by Sun. And as we are from this side of Earth, that is, if we on this side of Earth means nights at night time, we can get to see this planet throughout night. And it is completely illuminated by Sun. It is very close to Earth when compared to all the other positions in the orbit. So it is a good time to photograph or view these planets using telescopes. And this is what we have. And these are found above the horizon at all the night. So this year, August 14, Saturn will come at its opposition, and Saturn looks brighter than any other time of the year because it is completely illuminated by Sun, and it is the best time to view and photograph Saturn and its moon. We can even saw their moons also. And medium-sized or large telescopes can allow to see Saturn's rings and few brightest moons. In August 27, Mercury will be at its greatest eastern elongation with the angle 27.3 degrees. And this is also a best time to view Mercury. As it is an eastern elongation, we can get to see it in the evening sky, western evening sky. And September 16, Neptune will be at its opposition, and Neptune is far away from us, but it will be at the closest approach to Earth. So we can see this as a tiny blue dot, but in small telescopes. But if we use the powerful telescopes, we can get a clear view. And September 26, Jupiter will be at its opposition. So it is also somewhat far away from us. So we can, with the medium-sized telescope, we can see some details like Jupiter's cloud bands, and it's the 4 largest moons we can see during this time of year. And October 8th, Mercury will be at its greatest western elongation. So here, August 27, Mercury will be at its eastern elongation. So it have completed around half of its orbit, half of its rotation around Sun, and it is 18 degrees from the Sun. And this angles vary because these orbits are not so coplanar, and they not so coplanar. So the angles will vary on different times. And as it is in western elongation, we can get to see this on early morning sky, low in the eastern sky. And November 9, Uranus will be at its opposition. So Uranus will also comes closer to Earth, and it appears as a tiny blue-green dot, as it is a blue-green planet. So and it is at far distance, so it just appears as a blue dot, blue-green dot. And now December 8, Mars will be at its opposition, and this at this point of time we can see some of its dark details on the landscape with some medium-sized telescopes. December 21, Mercury will be at its greatest eastern elongation. Again, comes to that eastern elongation position, and it is 20.1 degrees from the Sun. Can be seen in the evening western sky. And January 30, Mercury again comes to western elongation, and this Mercury will come. Mercury's elongation positions will come very often because it is having a small orbital period. And May 29, Mercury will be at its greatest western elongation. And on June 4, Venus will be at its greatest eastern elongation and at an angle 45.6 degree when compared to Mercury's angle, that is 24.9 degrees, around 20 degrees. It is more because it is having a larger orbit. And another fascinating thing about thing we can observe with our naked eye with some help of some solar glasses, that is eclipses. Eclipses, commonly it is an astronomical event which occur when some astronomical object or spacecraft temporarily passing into the shadow of another body, but it is most commonly used to describe either solar eclipse or lunar eclipse. Solar eclipse means moon's shadow will cross the Earth's surface. So when people from Earth seems like moon is blocking the sun. And lunar eclipse, when moon moves into Earth's shadow. There are three kinds of these shadows. First one is umbra. This is a dark shadow. If the observer is in the umbra region, then it seems like we are in a total eclipse. We are seeing total eclipse. And if the observer is in penumbra region, it seems like the eclipse will be a partial eclipse. And if we are in antumbra region, we are far away from this obstacle. So this obstacle cannot seems to cover all the source, all the sun. So it looks like there is an annular ring around this particular moon. So in antumbra region, we will get to see partial eclipse. In the case of lunar eclipse, this antumbra region is far away from Earth's original orbit. So moon's orbit around the Earth. So we cannot we can't get lunar eclipse. We can't get to see annular eclipse with the moon. And during solar eclipse, we have to observe sky with some special solar filters, or we can look at sun's reflection. And if our eyes are in direct contact with the sun's rays, then it will cause permanent damage. So we have to avoid it. And this is total lunar eclipse. How does it happen? At some stage, when this eclipse comes to close to totality, there is only some places on the surface of moon where this sunlight can only able to come out of. So this looks like a ring, so it is called diamond ring position, and when it goes closer to totality, it looks like 2 or 3 beads in a chain. So it is called a Billy's beads. When it reaches totality, it completely covers sun, but only the corona of the sun is visible to us. So this is the best time to study about sun's corona by taking photographs or other observations. And this is how annular solar eclipse happens. Here at totality, even it reaches that particular instance of totality, it cannot able to cover total sun. So it looks like some annular ring around us, around the moon. And this is partial solar eclipse. It just covers a maximum amount of sun, then it the last contact. And for lunar eclipse, yet shadow is falling on moon, and it doesn't completely vanish moon. It seems like there is an dark, rusty red shadow is covering this moon's surface. So this red color is because here we are having sun. So sun it falling on earth through the atmosphere. Blue and green light gets scattered, and as it travels along the atmosphere, it gets refracted. Bending of light happens, and this light will reaches this moon's surface. So it looks like rusted green. So this year, August 25th, partial solar eclipse is going to happen in the parts of Western Russia and Kazakhstan. And this is best seen in central Russia with 80% of coverage. And in November 8th, we have total lunar eclipse. This is visible throughout Eastern Russia, Japan, Australia, Pacific Ocean, and part of Western and Central North America. April 20th, we are going to have a hybrid solar eclipse. In this solar eclipse, part of Earth's surface will be in Umbra region and part will be in Penumbra region. So some observers some places we will get to see total solar eclipse, some places we will get to see partial eclipse. Total solar eclipse happens in the regions Western Australia and Southern Indonesia, and partial eclipse will be visible throughout Indonesia and Australia. And May 5th, penumbral lunar eclipse. This occurs when moon passes passes through the Earth's partial shadow. So the moon will be in penumbra region of Earth's shadow. So during this time, it is visible throughout all of Asia and Australia and part of Eastern Europe and Eastern Africa. So this is all. Thank you.
Thank you, Nebula, for your interesting talk. Do anybody have any doubt to ask to Nebula? If there is anything, you can continue. Or even you can type in chat. Okay, then if not, let's proceed towards our next talk. Our next speaker is Asmitha MR from same integrated MSc Physics, Central University of Tamil Nadu. Let me welcome Asmitha to our talk. Over to Asmitha.
Thank you, Soundarya. Myself, Asmitha MR. I am from Central University of Tamil Nadu, Department of Physics, fifth year MSc Physics. Good evening to all. Good evening, ma'am. And I would like to thank my friend Nebula for giving such a nice introduction to various astronomical events. So here I would like to give an introduction to some of the major space missions that are going to happen in the coming year. So we should stay tuned for these missions, which are some of them are groundbreaking in space research. So let me share my screen. So can you see my screen?
Yes, Asmitha, continue.
Okay, thank you. So the first mission of the year 2022 was SpaceX Starlink mission. I hope you are all familiar with SpaceX, which is an aerospace company, private company, which was taking a lot of magnificent space endeavors. As we have seen the Inspiration 4 mission last year in 2021, right? They have carried 4 of their astronauts into the space, and they orbit the Earth, and they come back successfully. So now they are launching a Starlink mission, which is a satellite constellation development project, which aims to provide internet connectivity across the globe, even in remote areas through satellite constellations. As of May 2022, Starlink has already sent 2,400 plus more satellites into the orbit. This mission on January 6, 2022 was their 36th Starlink mission, and they have started this in 2019 itself. And this was the first Starlink mission on 2022 and first space mission on 2022. And they have in this they have made 49 internet satellites into the low Earth orbit using this Falcon 9 rocket of SpaceX. So this Starlink mission has attracted some criticisms as well, as the Kessler syndrome, like astronomical observers say. And a large number of satellites are placed in the orbit. So this might lead to serious satellite collisions as well, and also further collisions with space debris and asteroids and all. Also, these visible satellites are outnumbering these visible stars, which is affecting the astronomical observations. So these are some criticism against the Starlink, but even though they are carrying out their projects, and they are also trying to mitigate these problems by reducing the brightness of these or satellites and all. So we hope SpaceX will continue their endeavors in the coming year and in the future as well. We are looking forward to them. And the next mission was James Webb Space Telescope, which is a path-breaking mission in the astronomical observation. It is an infrared telescope, which is the largest telescope ever built, which is considered to be a successor of the famous Hubble Space Telescope. These things are very relevant in the fields of astronomical observations, as it can see back through the time, right? It can see too old and distant or objects which are faint for the Hubble Space Telescope, because this telescope is using an infrared technology. As we know, the already redshifted highly, so it will be very difficult to image them using this Hubble Space Telescope, which is using the visible and UV light. So in this, using this infrared light, we can see these images more clearly. And as you can see in this image, this is a comparison between different infrared space telescopes. First one is WISE W2, and the second one is Spitzer, and the last one is JWT. As you can see here, how resolved and how sharp this image is. So we can create a lot of such images using this JWST. We can study the formation of galaxies, formation of stars as well. And actually, we are looking back in time using JWST, even farther back in time, even the time of the formation of this universe. So this JWST is a a result of decades longer process, and research have been started in 1989 itself, and this one launched in 2021 December itself. Now in 2022, this has reached the L2 position of between Earth and Sun. L2 is the Lagrangian point between Earth and Sun, and it is 1.5 million kilometers away from Earth. It is positioned in a place where the heat or the light from Sun is not affected much, or the magnetic field of Earth is not affecting much for this telescope. And as of June 15, all of the instruments are on and have taken their image. So now we expect to see the first images released by the JWST. The NASA has already announced that they are going to release the first image of James Telescope on July 12, 2022. So we are expecting to see them soon. And then the next mission was ARTEMIS 1. It is a part of an ARTEMIS mission. And the ARTEMIS 1 follows ARTEMIS 2 and ARTEMIS 3 missions in future. The ARTEMIS 1 is a uncrewed mission into the moon. So this is actually going back to the lunar missions of, for NASA. They have already taken a lot of missions into moon as the Apollo mission, and now they are going back to moon again. So the ARTEMIS 1 is actually a test flight for the spacecraft Orion, as well as the rocket space launch system. The space launch system, as well as rocket, is said to be the most powerful one ever built, and it will be carrying the ARTEMIS mission forward. So this is a test flight from and is planned on August 2022. So we hope ARTEMIS 1 will be launched without any delays, and it will lead us to a new era of lunar missions, and also it is hoped to build a stepping stone into Mars missions. This is a video regarding the ARTEMIS mission 1 mission, how it is going to orbit the Earth and the Moon. So it will only orbit the Moon, and it will come back into the Earth orbit, and it is a 26 to 42 days mission, and it is the test flight for ARTEMIS mission. So the story about ARTEMIS mission. And another one I need to introduce you to is Axiom 1 mission, or X1 mission. This is a private mission and entirely funded by the company Axiom Space, and in collaboration with SpaceX as well. The spacecraft used the Crew Dragon by SpaceX, and it is the first all-private astronaut mission into the International Space Station. We know Inspiration has already carried 4 of their astronauts into space, and is the one which carrying their astronauts into International Space Station for the first time. That is all for the first commercially funded mission into the ISS. So this is already launched on 8 April 2022, and it came back on April 24. But after carrying out a lot of STEM researches in the ISS, the space jewelry which can be used in under microgravity and the International Space Station. So that's all about Axiom 1, and you can see the crew members of Axiom 1 here. That's Michael Lopez, Algeria, and Larry Corn, Ethan Stepe, and Mark Padi. Among them, the one I need to introduce you is Larry Corner, who is the first person to travel to space and depths of ocean in 1 year. He has, over the course of 5 days, he completed 3 dives to the Challenger Deep, Serena Deep, and Seamount in the Mariana Trench. He also went to the International Space Station. It was an interesting achievement in the life of this person, right? So now let us move on to the missions of ISRO. ISRO has been carrying out a lot of space missions, right? Like Mangalyaan, and they were stunting in their missions. We know ISRO started late comparing to NASA and the Russian Union. So even though their achievements are far higher than expected. So now ISRO is planning for third lunar exploration mission, that is Chandrayaan-3. This is actually a repeat of the Chandrayaan-2 mission. Chandrayaan-2 mission, as we know, it failed to soft land on the south polar region of Moon. So we are going to carry out a third lunar mission to soft land on the south polar region of Moon, which is named as Chandrayaan-3. This is planned to launch in 2023, and it is by the GSLV Mark III rocket launch vehicle, which is the pride of ISRO actually. And if we have accomplished this mission, India will become the first nation to soft land on the south polar region of Moon, and will be the fourth nation to soft land on the Moon. So we hope Chandrayaan-3 will be Aditya L1. This is a solar mission, and it is the first solar mission of India. It will study the sun's corona mainly and its photosphere and chromosphere. It will be inserted in the hollow orbit around the Lagrangian point L1 between Earth and Sun, and its planned launch date is January 2023. Actually, Aditya L1 and Chandrayaan-3 have already planned earlier, but due to the COVID outbreak, it was delayed due to many constraints. So it couldn't make it to the space, but we hope without any further delays, Chandrayaan, Aditya L1, and actually Gaganyaan, I am going to talk about it. So these are all the missions of ISRO going to happen in the coming future. So Aditya L1, the rocket launch vehicle, is not GSLV-3, it is GSLV XL, and it will be able to provide observations of sun's photosphere, chromosphere, and the corona. In addition, an instrument will study the solar energetic particle flux reaching the L1 orbit, while a magnetometer payload is also included to study the interplanetary magnetic field and the magnetic field at L1 region. This is the Aditya L1, and it includes 7 payloads, including the visible emission line coronagraph, and SUIT, SDX, and TAPA, and finally a magnetometer. And these are the images of this spacecraft. And then there are other solar missions as well, a part of Aditya L1 of India, which is NASA's Parker Solar Probe, NASA's Living Detail Star, and NASA's Helios 2. We hope these missions are success and we could learn more about the sun's corona. As you know, sun corona is at a temperature of more than 6,000 Kelvin centigrade. So it is very difficult to study about sun, but we hope we will get a more understanding about sun through this mission. And the final one and important one for India is Gaganyaan. Gaganyaan is the first human space flight mission of India, and it is the ambitious mission of India, which were planned a lot of time ago. So Gaganyaan mission is planned to launch its first test flight in 2021 itself, but again due to the COVID outbreak, it was delayed further. It plans to carry 3 astronauts into space, and they plan to spend almost 7 days in space. Its duration is said to be 7, which is much more higher than the usual human space endeavors. Usually the time is 2 to 4 days maximum, but ISRO aims to send their astronauts 7 days into space. So we hope it is it will be a success. As you know, human missions are much more complicated and they requires a lot of efforts and lot of checking before the mission. So it is getting delayed, and it is planned to launch the first test flight to be planned to launch on 2020, early 2023. The 4 cosmonauts for the Gaganyaan mission has already completed their training in Russia's Yuri Gagarin Cosmonaut Training Center. And now they are undergoing training in Bangalore's training facility. And we hope they will do their best for this mission. And I would like to introduce you to a female humanoid robot. You can see in the picture that is Humanoid Vyommitra, which is manufactured by ISRO, and it was introduced on 22nd January 2020. This Vyommitra is a humanoid robot which will accompany the crewed and uncrewed missions of Gaganyaan, so that it can mimic human actions and it can study various aspects of the space on human body. So as you can see, it can monitor module parameters as well. It can make different experiments, and it can measure your heart, this pulse, and all in the space. So that is about Humanoid Vyommitra, and these are the major new technologies required for the Gaganyaan program, as it is a human spaceflight program. We need human rated launch vehicle, crew escape system, habitable orbital module. As we are already discussed that they are going to spend almost 7 days in space, so they need a better planning about the orbital module and the life support system, and we need a crew selection and training and associated crew management activities.
Practically mumbling. You're mumbling, you're talking to yourself. Can you speak more loudly and clearly?
Yes, ma'am.
Please speak more loudly and more clearly. You're mumbling to yourself.
Sorry, ma'am. I will try. So this is the final mission I am going to talk about, that is Gaganyaan. Gaganyaan is carried out by various agencies in India, not only ISRO, with ISRO, Indian Armed Forces, Indian Navy, Defense Research Development Organization, that is DRDO, and various academic institutes and industry partners are all coordinating with the Gaganyaan mission, as you can see here. And also our first man who flew into the space from India, that is Rakesh Sharma, you know, right? He went to space as part of Russian Soyuz 11 mission, but now he is coordinating with the Gaganyaan mission for India's first human spaceflight program. So he is contributing his best to the program, and we hope the Gaganyaan mission would be a successful event, and it will lead us to a groundbreaking mission, and it will lead us to a new era of space mission for India. So here I stop my presentation. That's all about the space missions of 2020 to 2023. There are many more missions going to happen, which I haven't discussed here, like site mission to asteroids, and then there are many more missions which is going to take place. I hope you will get updated about these missions, and we will get more understanding about the astronomical missions in the future. Thank you.
Thank you, Asmitha, for your informative talk. Participants, do you have any questions? If there is any questions, you can ask to Asmitha, or you can even type in chat.
Okay, before the students ask anything, I would like to first of all thank Nebula and Asmitha for both talks were very informative. Thank you very much, and I think it's very much needed. Just a small piece of information, it's not official right now, but we may be able to get some telescopes soon, to the not for VINN, but to the department in certain sense. I'm trying my best. And if that happens, we'll also try and have a solar telescope so we can track the motion of sun that one of you were mentioning. So fingers crossed, maybe, by beginning of 2023, we might have some telescopes within the department, and that will help us to understand these concepts in a better way. I just wanted to share that with you, but we are trying for something. I'm trying for funding so that we can buy some basic telescopes.
Thank you, ma'am.
Thank you, ma'am, for your initiative. And we are really interested to have a telescope in our department before we leave.
I think we can have some experience with it.
I understand and I'm trying my best. Let's see. Just hope for the best. Let's see if it works.
Okay, thank you everyone for attending today's webinar, and a special thanks to two of my classmates who were speaker today, Nebula and Asmitha. And thank you one and all. Have a great day.